You're welcome, everyone. In this video, we are going to be looking at how to solve problems on indices. But in order for you to have better familiarity, more experience regarding the laws of indices that we have treated in our previous video, so we're going to be starting from simple problems, then we'll be graduating to complex ones so that you have better knowledge about solving problems on indices. So I'm going to be starting from simple ones, then we'll be gradually upgrading to complex ones. So based on this first problem that we have here, it says 10 raised to the power of 9 times 10 raised to the power of 12. As you can see, the base are the same. So they have the same base and there is multiplication between them. So when you are multiplying the same base, so what law will you use? So it's going to be equal to 10 raised to the power of 9 plus 12. So when you have situation like this, you know that you have to add the power. So you're going to have 10 raised to the power of 21. And that's how you go about it. Now let's quickly look into the second exercise. So the question says 18x raised to the power of 8 divided by 6x raised to the power of 5. So in situation like this, it's easy to see that it's going to be 18 divided by 6 because these are the two numbers that we have there. So 18 divided by 6. Then we also have multiplied by x raised to the power of 8. So times x raised to the power of 8. And I can also say divided by x raised to the power of 5. So I just had to separate them, numbers from the letters. So I separated the coefficient from the variables there. So in situation like this, so 18 over 6 is 3. So I can use, since it is division, so division of the same base, so that means I'm going to be subtracting the power. Then we're having 3x raised to the power of 8 minus 5. So the final answer is 3x raised to the power of 3. And that's how you go about this. Very simple. Now let's look into another problem. Now this third problem says x raised to the power of minus 4 times x raised to the power of minus 5. As you can see, the bases are the same, common base. So all we do is, and there is multiplication between them, so we just add the power. So it's going to be equal to x raised to the power of minus 4 plus minus 5. And as you can see, it's going to be x raised to the power of minus 4 minus 5, because the product of plus and minus will give you minus. So minus 4 minus 5. And the final answer is x raised to the power of minus 9. Now let's progress to more problems. It says a raised to the power of minus 4 multiplied by a raised to the power of 4. So we are still going to be using the same law. It's going to be equal to a raised to the power of minus 4 plus 4. It's going to be a raised to the power of 0. And don't forget, one of the laws of indices is when you have 0 power, 0 index. So the answer is 1. So let's move to the other example. Before solving this, you need to take note of a negative index. One of the laws says when you have a raised to the power of minus 1. So when the index is negative, that is when the power is negative. The negative means 1 over. Then you say a raised to the power of whatever power that is there, that's 1. So, and that's one of the part of the numbers that we have in this question, saying 1 over 8 all raised to the power of minus 1. So the negative index signifies 1 over. So let's quickly progress. So we have equal to 2 raised to the power of 4 is 16. That's 2 times 2 times 2 times 2. 2 multiplied by itself 4 places. That's 16. Then times, because of the negative index, I will say 1 over, then 1 over 8 now. 1 over 8 raised to the power of 1, which is still the same thing. Then multiply by 4 raised to the power of 0. And don't forget, a raised to the power of 0 equal to 1. That is, any number raised to the power of 0 is 1. So 4 raised to the power of 0 is 1. So it's going to be equal times 1. So we have equal to 16 times. So I'm going to be changing the division sign to multiplication, and in situation like this, it's going to flip over. That is, the 1 over 8 is going to flip over to 8 over 1. It's going to be times 8 over 1. Then times 1. So 16 times 8 is definitely going to be 128. Or I can raise all to the power of 2, which is going to be 2 raised to the power of 4 multiplied by 2 raised to the power of 3, because 8 is also 2 raised to the power of 3, which is going to be 2 raised to the power of 7, or you can say 128. So this is how you go about it, and this is how you get familiar with the basic rules of indices. Now let's progress to other examples. Here we have 12p raised to the power of minus 5, q raised to the power of minus 6 divided by 3p raised to the power of minus 8, q raised to the power of 10. So how do we go about this? So it's going to be equal to 12 divided by 3, because the division is the relationship. So 12 divided by 3, that's 4. Then we have p raised to the power of minus 5 divided by p raised to the power of minus 8. So when the base are the same and there is division as the relationship they share, so we are going to subtract the powers. So it's going to be p raised to the power of minus 5, then minus 8. Then you do the same thing for q. It's going to be q raised to the power of minus 6 minus 10. You subtract the powers. Then the final answer is going to be equal to 4p raised to the power of minus multiplied minus is going to give you plus. That's minus 5 plus 8. And minus 5 plus 8 is 3. So we have 4p raised to the power of 3. Then q raised to the power of minus 6 minus 10 is minus 16. Minus 16. And that's the answer. So let's look into other examples. Now, 27 raised to the power of x minus 1 times 27 raised to the power of 1 minus x. So the base is the same, so we have to add the power. So it's going to be equal to 27 raised to the power of x minus 1 plus 1 minus x. This is going to be equal to 27 raised to the power of x minus x is 0. Then minus 1 plus 1 is also 0. So that's 27 raised to the power of 0, 0, and the final answer is 1. Into brackets, then a smaller bracket, 3g all raised to the power of 2, then all raised to the power of minus 2. In situation like this, you're going to be applying the product of product rule. That is where you have a raised to the power m in bracket, then outside raised to the power n. So in situation like this, you are going to be multiplying the powers. It's going to be equal to a raised to the power of mn. And that's the same thing we're going to be using here. So it's going to be equal to 3g raised to the power of 2 times minus 2. And that's going to be equal to 3g raised to the power of minus 4. The minus 4 is for both 3 and g, because they are both enclosed in the bracket. So which is going to give us 3 raised to the power of minus 4 then times g raised to the power of minus 4. And when you have a negative index, negative power, it signifies 1 over. That is, a raised to the power of minus 1 means 1 over a. A raised to the power of minus 2 means 1 over a raised to the power of 2. So and that's what we are going to be applying here. Which is going to be equal to 1 over 3 raised to the power of 4 multiplied by 1 over g raised to the power of 4. And the final answer is 1 over 81, because 3 raised to the power of 4 is 81, multiplied by 1 over g raised to the power of 4. Then bringing the both of them together, the final answer is 1 over 81 g raised to the power of 4. Or you can get your answer even from the onset, but simplifying further, this is your answer. So let's move to another example. Now, this question is almost similar to the last question that we just did, but there is a slight difference. The difference is we are having two powers also, 6 and 4. But you need to understand something. The 6 is for x alone, while the 4 is for both x and for minus 2. Now let me take you back to the last question. Now as you can see, we have enclosed in the bracket is where we have 3g, then we have raised to the power of 2. It signifies that the power 2 is for both 3 and for g. And also the power of minus 2 that we have here is for both 3 and g, because they are all enclosed in the bracket before getting the power. But it's different from this. The x is only for, the 6 is only for x, it's not for the minus 2, while the 4 is for both x and minus 2. So we are going to be separating them, so which is going to be equal to, so the 4 is for minus 2 also, going to be minus 2 raised to the power of 4, as you can see, then multiplied by, the 4 is for x also, x raised to the power of, then 6 times 4, 6 times 4, 6 times 4, so which is going to give us minus 2 raised to the power of 4 is going to give you 16. It's going to give you a positive number. Now how do we know? Now when you have minus 2 raised to the power of 4, it means minus 2 times minus 2 times minus 2 times minus 2. That is, you multiply minus 2 in 4 places. So 2 times 2 times 2 times 2 gives you 4, gives you 16. But how do I know when to put negative and when to put positive? So I'm going to be multiplying the negatives also. This minus multiplied by minus is going to give you plus. Then the plus that you have gotten here multiplied by this minus is going to give you minus here. Then the minus you have gotten here multiplied by another minus is going to give you plus at the end of the day. And that's why the result is 16. So in short, when you have a negative number, that is minus 2, and the power is an even number, say 2 or 4 or 6 or 8 or 10 or 12, so far the power is an even number, the answer you're going to be getting is going to be positive answer. So minus 2 all raised to the power of 2 is the same thing as 4, so it's not going to be a negative answer. So take note of that. When you have the power which is an even number, while the base is negative, as in this case, so the answer is going to be positive. But if you have the base minus 2 raised to the power of minus 3, if the power raised to the power of 3, sorry, if the power is odd number, as in 3, 5, 7, 9, 11, So as many odd numbers as you can, think of. So if the power is odd number, the answer you're going to be getting is going to be negative, because it's going to be minus 2 times minus 2 times another minus 2. So you know that 2 times 2 times 2 is 8. But minus times minus is going to be plus here. Then plus times minus will give you minus, so minus 8. So, and that's just the shortcut to quickly, get into understanding if your answer is going to be positive or negative. So in situation like this now, this minus 2 raised to the power of 4 is going to give me a positive answer, because I already established that fact. So it's going to be 16, then multiplied by x raised to the power 6 times 4 is 24. So 16x raised to the power of 24. So let's move to another example. So the question says we should solve 16 raised to the power of 1 over 2. Don't forget, we're going to be using a fractional index. So that is, when you have a raised to the power of m over n, when the power is fraction. I told you in our last video that the denominator becomes the root, while the numerator becomes the power. And that is what we are going to be applying here. So we have a fraction as our index. So that's 1 over 2. It means the denominator, which is 2, becomes the root, while the numerator, which is 1, becomes the power. So the answer here is going to be square root, because the denominator is 2. So square root of 16 all raised to the power of 1. So I don't need to write raised to the power of 1, because anything raised to the power of 1 still remains the number. So root of 16 is 4. So the final answer to this is 4. So without you even stressing yourself, you can just immediately, once you are familiar with the rules, with the basic rules of indices, quickly get your answer and you leave. Next example. The question says the square root of 25b raised to the power of 4. So it's easy, because the square root of 25 is 5. While the square root of b raised to the power of 4 is b raised to the power of 2. So it means the square root of b raised to the power of 2 will also be b raised to the power of 1. So it means the square root of b raised to the power of 6 will be b raised to the power of 3. So it's just like, since it is square root, it's just like dividing by the root, which is 2. So when you divide 4 by 2, it's going to give you, by 2 is going to be giving you 2. So the answer to this is 5b raised to the power of 2. So let's move to the next example. It says 27 raised to the power of minus 2 over 3. So we are looking at two things here. It's a negative index, and at the same time it's a fractional index. So I'm going to be sorting out the negative index. Don't forget, I told you already that when you have a negative index, as in a raised to the power of a negative number, minus 1 or minus 2 is going to be 1 over. So in this case, 1 over a raised to the power of 1. So that's what we're going to be applying here. So because of the negative index, I'll quickly write, it's going to be 1 over 27 raised to the power of 2 over 3 now. 2 over 3. Then the 27 raised to the power of 2 over 3 is now having a fractional index, and I've explained that. When you have a fractional index, the denominator becomes the root, while the numerator becomes the power. So it's going to be equal to 1 over, the root now is going to be cube root, because the denominator is 3. So cube root of 27, everything raised to the power of 2, because numerator is 2. So it's going to be giving us 1 over, the cube root of 27 is 3. So 3 raised to the power of 2. And the final answer is 1 over 9. And this is how you progress. Next example. It says 9a squared over 25, all raised to the power of minus 1 over 2. So it's very simple also, because we're having a negative power here. So which is going to be signifying 1 over, then we have 9a squared over 25 raised to the power of 1 over 2. So we are having a fractional power. And don't forget, the denominator becomes the root while numerator becomes the power. So this is going to be equal to 1 over the square root of 9a squared over 25. Of course, the square root of 9a squared is going to be, we have 1 over the square root of 9 is 3. The square root of a squared is a over square root of 25 is 5. Of course, we are going to be inverting 3 over 5, 3a over 5 to become 5 over 3a because it is an inverse. 1 over is a reciprocal. So it's going to be equal to 1 times, then we have 5 over 3a. So the final answer is 5 over 3a. This is almost the same as the last question. So we're going to be applying the same rule. It's going to be equal to 1 over 4x squared over 9 all raised to the power of 1 over 2. Then we are going to be applying fractional index rule. It's going to be 1 over, then we have the square root of 4x squared over 9. And what is the square root of 4? We have 1 over the square root of 4 is 2, square root of x squared is x, then over the square root of 9 is 3. So this is going to be 1 times 3 over 2x. So the final answer is 3 over 2x. Now this is straightforward. All we just need to do is we can apply the fractional index law. It's going to be cube root of 27x raised to the power of 3. Don't forget, the denominator becomes the root, while the numerator becomes the power. And here, the denominator is 3 and numerator is 1. So you have the cube root of 27 is 3. Then the cube root of x raised to the power of 3 is x. So the answer is 3x. Now this question says you should solve 0.0081 all raised to the power of 1 over 4. You can see this is a decimal number given to you. And let me quickly note something. When you have a decimal number in indices like this, so it is best, the best thing you do is convert it to fraction. So you have 0.0081 is going to be equal to 81 over 10,000 if you have to convert into fraction. So that's 81 over 10,000 all raised to the power of 1 over 4. So convert into fraction, and that's how you'll be able to get it done. And don't forget, fractional index is going to be equal to the fourth root. So the fourth root of 81 over 10,000. And the fourth root of 81 is 3. That is, when you multiply 3 in 4 places, it's going to be equal to 81. That is 3 times 3 times 3 times 3. It's going to give you 81. So the final answer here is going to be 3 over the fourth root of 10,000 is 10. That is, when you multiply 10 in 4 places, because the root is fourth root. So multiply 10 in 4 places, it's going to give you 10,000. 10 times 10, 10 times 10, 10 times 10. So do the workings, it's going to give you 10,000. So 3 over 10 is the final answer. And so we have come to the end of this video section. So please do well to subscribe, like, and share. Anticipate for more problems. In the next part of my video, I'm going to be solving complex ones. So equations in indices and some other exponential equations, different ones. And if you have problems that you really would like me to help you with, please do well to share them with me. You are great.